Imagine for a second that you're sitting in the driver's seat of a machine worth more than a typical family home. You smell the hand-stitched Italian leather. You hear the absolute silence of the cabin, and you feel the raw, coiled power waiting beneath the hood. Most people look at a luxury car and see status, but I look at it and see a miracle of human persistence. What if I told you that the vehicle you're admiring started its life in a dark, high-pressure mine thousands of miles away? Every single piece of this machine is a traveler, having crossed continents before it ever reached the assembly line. We aren't just talking about steel and plastic. We're talking about rare earth magnets, ethically sourced wood veneers, and aluminum alloys that have been refined to aerospace standards. You think you know how a car is built, but here's what nobody tells you. The process is more like a symphony of extreme physics than a traditional factory line. And this is where it gets truly extraordinary. Before a single bolt is turned, we have to talk about the hidden origin of these machines. That shimmering aluminum chassis? It likely started as bauxite or pulled from the red earth of Guinea or the rainforests of Brazil. It takes roughly 4 tons of raw bauxite to produce just 1 ton of aluminum, a process that consumes massive amounts of electricity and generates heat so intense it could liquefy the air in the room. Most people never think about the sheer environmental debt that has to be paid just to get the raw material to the foundry. The supply chain is a labyrinth of global logistics, where a delay of just 10 minutes in a port in Shanghai can cause a factory in Germany to go completely silent. We are tracking thousands of parts from over 30 different countries. The leather, for example, is sourced from high-altitude farms in Austria, where the cooler climate keeps the cattle free of insect bites, ensuring the hide is absolutely flawless for your seats. But what happens next in the refinery surprised even the most experienced engineers I've interviewed. Once those raw materials arrive, they are subjected to a transformation so violent it feels like alchemy. We start with the casting of the engine block. We are talking about molten aluminum heated to exactly 720 degrees Celsius or 1,328 degrees Fahrenheit. It is poured into sand molds at a pressure of 150 bar to ensure zero microscopic air bubbles, because a single bubble in the engine block is a death sentence for the vehicle's performance. The sound in this section of the plant is deafening, a roar that vibrates right through the soles of your shoes. Next, the frame moves to the robotic welding station, where 400 precision robots work in a synchronized dance. These machines don't just weld. They use laser vision systems to ensure every spot weld is accurate to within 0.05 millimeters. That is half the width of a human hair. They move at a rate of 1.5 meters per second, completing an entire chassis assembly in under 3 minutes. If these robots were even a fraction of a millisecond out of sync, the frame would buckle under the stress of the car's own engine. After the structure is rigid, we enter the paint shop, a pristine, dust-free environment where human hands are strictly forbidden. The car body is dipped into a series of chemical baths, including an anti-corrosion primer that is electrically bonded to the metal at 400 volts. Then comes the color coat, applied in 3 distinct layers, each baked at 140 degrees Celsius for 45 minutes to achieve that liquid mirror finish you see in the showroom. But wait, what happens if one tiny speck of dust lands on that wet paint? The entire panel is scrapped. Now we reach the heart of the machine, the final assembly, where technology finally meets human intuition. Robots handle the heavy lifting, such as installing the glass roof or the drivetrain, but the luxury elements are strictly manual. A master artisan spends 4 hours hand-stitching the steering wheel leather, ensuring the tension is perfectly uniform. If a machine did this, the leather would tear. It takes the human eye to detect the subtle imperfections in the hide that a sensor would simply ignore. Quality control is where the real stress begins. Every vehicle is placed on a 4-poster shaker rig that simulates 100,000 miles of driving in just 6 hours. We are testing for rattles, squeaks, and structural fatigue. If a single plastic clip vibrates more than 0.2 millimeters at high frequency, the entire interior panel is pulled and replaced. The rejection rate for luxury components is high, often reaching 4%, because the brand cannot afford a single failure. You've heard of AI in cars, but here's a shocking fact. The sensors in the factory are now so advanced they can predict a mechanical failure before it happens by listening to the sound frequency of the assembly tools. They call this acoustic AI. It hears the difference between a bolt being tightened correctly and one that is being stressed too far. Most people don't realize that the factory itself is a living, learning organism that improves its own efficiency every single day. Let's zoom out to the global scale for a moment. Every year, the world produces roughly 90 million vehicles, but the luxury segment accounts for less than 1% of that total. That is a market worth over $500 billion globally. The top 5 manufacturing powerhouses, Germany, Japan, the United States, South Korea, and Italy, control the lion's share of this prestige market. It's an industry that employs over 10 million people directly, and the ripple effect supports millions more. Think about this. 50 years ago, building a car like this required a massive workforce of thousands of men using manual tools. Today, we achieve higher precision with a fraction of the human labor, yet the cost of these vehicles has soared. Why? Because the engineering complexity has increased 1,000-fold. We are cramming the computing power of a 1990s supercomputer into a device that has to survive temperatures from minus 40 degrees Celsius in Alaska to 50 degrees Celsius in the Arabian desert. Did you know that some high-end luxury cars have more lines of code than a commercial jetliner? We're talking about over 100 million lines of software. And did you know that the paint on a luxury vehicle is often thinner than a human hair, yet consists of 7 different layers of chemical protection? The most shocking fact, however, is that some of these cars are still tested by humans who drive them at triple-digit speeds on private tracks before they're even allowed to be shipped to a dealer. We have walked through the mines, stood in the fire of the foundry, and seen the digital brains of the modern factory. You've seen how we turn raw earth into a status symbol, a piece of art, and a marvel of physics. It's a process that never truly stops, even when the car is finished and sitting in your garage. The lessons learned in the factory are already being uploaded to the next generation of designs. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.